Okay, these quadrilaterals all have sort of similar properties, so we just have to know how they work, and then we can find out how we can prove that they are congruent. So a kite has two pairs of adjacent sides that are equal to each other. So we don't know how long this is, but we know that that is equal to that. One diagonal of a kite bisects the other diagonal. So this one is being bisected. So that means that this half is equal to that half. And this one cuts it in half. So these angles are not equal, but they are being bisected. And we know that the diagonals of a kite are perpendicular, so they're at 90 degrees. So trapezium, there's not much we can lean on except that there are two sides that are parallel. At least one pair of sides of a trapezium is parallel to the other. A parallelogram has parallel sides, a pair, and another pair of parallel sides. The opposite sides are equal, so that one's equal to that one, and that one's equal to that one. And the opposite angles of a parallelogram are equal. So this angle will be equal to that angle, and this angle will be equal to that angle. And they bisect each other. So this is the same as this. This is the same as this. So they bisect means to cut in half. So they're each equal to each other. A rhombus is getting pretty close to a square. So we have parallel sides and parallel sides. We have all sides being equal. We have diagonals meeting at a right angle, so they're perpendicular. And these diagonals bisect each other. So a rhombus is pretty cool because this half equals this half, and this half equals that half. So they are cut in twain. A rectangular, parallel, equal, all 90 degrees. And here's our diagonals. Look at that. That gets cut in half by this diagonal, which is also being cut in half. Pretty cool. And a square, opposite sides of a square are parallel. So parallel to parallel, parallel to parallel. All sides are equal. Diagonals bisect and meet at 90 degrees, which makes them perpendicular. Now, the tricky part is here to prove that diagonals of a parallelogram bisect, so they're equal on each half, and give reasons. So the funky thing we're going to do is we're going to draw DC, CA, AB, like this. So we're going to make them into triangles. So what we really have is two triangles. So we've got triangle AEB, and I'm going to take this triangle and I'm going to flip it around. So we've got, if I flipped it around, we would have D, is that a C? C, E. So now we have that A corresponds to C, B corresponds to D, and E corresponds to E. So if we can prove that these triangles are congruent, then we can prove that these side lengths are the same. So for example, if we could prove that AE is the same as CE, which is here AE and CE, we can prove that they are bisected. So let's look. So if A corresponds to C, which it does, then we have these angles that are the same. If D corresponds to B, I need a different symbol there. These are the same. Of course, AE is going to be the same as E, because E is E. And if we look at it, they're vertically opposite. So now what we have is proof that they are congruent. So we have A, because this and this are alternate angles, meaning they're equal, which proves what we've got here. And this B, at vertex B, the angle at vertex B, and the angle at D, they are also alternate angles. So they are equal. And of course, vertically opposite angles are equal. So we have congruent triangles. And if we have congruent triangles, then we know that this length from A to E is going to be equal to this length from C to E. And we also can tell that, if we're in the mood, that from D to E is the same length from B to E. So they are truly and properly bisected. There you go.